this presentation and we try to finish that presentation and then we will stop. Now see here, first order spectra and second order spectra. You can also have a third order spectra, fourth order spectra and so on. But we are not going to see in detail fourth, fifth and complex spectra. Already we have seen the complex spectra, but we have to consider here what is first order spectra and what is second order spectra. You will have the question in the examination, what do you mean by first order spectra and what do you mean by second order spectra. Now see this part in detail. For a spectrum which is called as or to be called as first order spectra, when delta V between the chemical shift of any given pair of nuclei must be much larger than the value of the coupling constant J between them. Now see here, what is chemical shift and difference between the chemical shift is called as delta V. When delta V divided by J, it is greater than 10. It is greater than 10. When this value is come less than 10, then we will observe that first order spectra. Once again, I repeat the same. The first order spectra, the when delta V between the chemical shift of any given pair of nuclei must be much larger than the value of coupling constant J between them, that is delta V divided by J is greater than 10. When this is the equation, then you will get first order spectra. What is the first order spectra characteristics? So they are having lot of characteristics. First order spectra exhibit the following characteristics. Number one, the spin-spin multiplates are centered on the resonance frequency. Spin-spin multiplate means what? Spin-spin multiplates are centered on the resonance frequency. Suppose if we have a triplet, so you know that triplet having some height means first peak having some height, second peak having another height, or second peak is larger than the first one and third peak is again similar to the first one, right? So triplet, you remember the triplet, and this triplet, whatever we got this peak, that should be according to the resonance frequency, or it should be centered, means center peak should be the larger compared to the side peaks. So this is the one thing, that is spin-spin multiplate. Another important thing that I want to mention, that when we consider CH3, CH2 dash, CH3, CH2 dash, if I ask what is the splitting pattern of CH3, first CH3, definitely neighbor is the CH2. So n is equal to 2. So 2 plus 1 is equal to 3. Therefore it shows triplet. So CH3 shows the triplet. And this is the splitting pattern of that particular molecule according to the resonance frequency. So this is the normal one. So whatever things we are observing generally, all things are showing the first order spectra. What is the second order spectra, that we will see later. But first order spectra, to obtain the first order spectra, the condition is that delta V upon delta J is greater than 10. Always it is greater than 10. That ratio is greater than always 10. This is the first cause or characteristic. Second reason is that, or cause is that, spacing between the adjacent component of the spin-spin multiplate, that is the J. So there should be the splitting is there. Means you will not get very complicated spectra. There should be some distance between two peaks. If you are getting the two peaks separately, you can see that this is the first order spectra. If the peak is not isolated, peaks are not separated, they are complex, you do not see that it is first order spectra. Now, multiplicities that result from coupling exactly reflect the n plus 1 rule for I is equal to 1/2, means spin quantum number is equal to 1/2. For example, look at the students. CH3, CH2OH, it is well known to you that ethanol. When we call as ethanol and splitting pattern of ethanol, first of all, how many different type of peaks are observed? Definitely there are three different peaks because three different type of protons are observed. CH3 first proton, CH2 second proton, and OH is the third proton. So likewise, you will get three peaks. If I ask what is the splitting pattern of CH3, the splitting pattern of CH3 is by using n plus 1 rule. So you can apply the n plus 1 rule, and you know that the neighbor of this CH3 is CH2. So 2 proton of CH2 coupled with the 3 proton of CH3. Therefore, by using n plus 1 rule, put the value of n is equal to 2, where n is equal to 2, and that gives 2 plus 1, that is equal to 3. And therefore, you are getting the triplet. Whenever this kind of situation is coming, exists, and this n plus 1 rule is applied to the particular molecule, and according to that n plus 1 rule, you are getting this multiplet. Definitely it is first order spectra. Definitely it is the first order spectra. So this is the second characteristics. And third one is that the intensity of the spin multiplets correspond to the coefficient of the binomial expansion given by the Pascal triangle for spin 1/2 nuclei, just like a CH3 CH2OH. Now, you know that the Pascal triangle, I have shown this Pascal triangle here. Means when I am having the singlet, in that case, in case of n plus 1 rule, I will get n is equal to 1, therefore singlet. When I am having the doublet, I can get n plus 1, n1 plus 1 is equal to 2, I can get doublet. When I am getting the triplet, I have to use this, look at this, 1, 2, 3, like and so on. So likewise, you can get singlet, doublet, triplet, quartet and quintet. Now how it is matching it, how it is binomial expansion. Binomial expansion means what? This A, you are looking this A very well. When we move from the move to the left hand side, you are getting the 1. When you move to the left hand side, you are getting the 2. Sorry, 1. So this 1 plus 1 is equal to 2. Therefore, it is showing the doublet. Now, when you go for the next, this will, when you go for the next left hand side, again you will get 1 here. And when you move to the middle, when you move to the middle, and just you add 1 plus 1, this 1 plus 1 is getting the 2. So 1 plus 1 getting the 2. So 2 is obtained, and again 1 to the right side is coming over here. So 1, 2, 3. So you will get the triplet. You will get the triplet here. Again, when we go for the quartet, during that time, you look at this first one, this one which is present at the left hand side, and you look at this left hand side 1 that is coming under like this similar way. And whatever next 3 is obtaining, that 3 is due to the addition of this 2, 1 plus 2. This 1 plus 2 is coming the 3. And again, this 3 is coming by the addition of 2 plus 1. This 2 plus 1 is equal to 3. And again 1 to the right side coming like that. So you will get 1 has to 3 has to 3 has to 1, and that shows the quartet. So by that way, it is the showing the Pascal triangles. It is showing the Pascal triangle very well. So by using this, you can understand the concept very well. And this is the third characteristics of this first order spectra. I have written once again here, whatever I have in the triplet for the CS3 and the quartet for the CS2 and singlet for this OH. So CS3, CS2, OH, the splitting pattern is of, when I am having the triplet, it is 1 has to 3 has to 1. And when I am having the quartet, 1 has to 3 has to 3 has to 1, and singlet is 1. So by that way, you can have 3 characteristics or more characteristics of this one. Now see here, when the chemical shift difference is less than about 10 times J. The chemical shift difference is less than 10 times J. The second order effect appears in the spectra. When first order is getting and when second order is getting. In that case, in first order spectra, we have seen that the chemical shift difference is less than about 10 times J. About 10 times J means what? If J is 100, then chemical shift should be 10 only. or when J is 10, the chemical shift is 1. In that case, that difference is less than 10 times J, then it is appear as a second order spectra. So including the deviation in the intensity from the binomial pattern and other expectation from the preceding characteristics. One more point that is called as Pople notation. Pople, P-O-P-L-E, Pople notation. Nuclei that have first order relationship are represented by the letter that are far apart in the alphabet. It is called as AX. Generally, what happen in case of first order spectra, we are written AB, neighboring carbon atom. But in this case, we have written AX. Remember here, first carbon atom having the number A and last carbon atom number having the X. What's about B, C, D, and other letters? They are in between that A and X. Even though this is also called as first order spectra. Another, nuclei that are close in the chemical shift and may exhibit a second order relationship are represented by the adjustable letter AB. So nuclei, they are close to each other. Nuclei, they are close to each other, but they are showing the second order spectra. They are showing the second order spectra. In that case, notation is written as AB. And Pople notation, what it indicate? AX. AX, one can remember that the first carbon atom having A number and last carbon number having X. Means lot of carbons atom, but they are matching together and they are showing the first order spectra. And the protons which are close to each other means adjacent protons are attached to each other, or each carbon of proton, if they are coupling with each other and they are showing the second order spectra, in that case it is called as AB spectra. The nuclei in the middle of AX are represented as M. The higher field spectrometer, that is 300 megahertz, increases the delta V, that is 1 ppm, represent a greater number of HZ and minimize second order spectra. See here, what will happen in case of higher field spectrophotometer? Means those instruments are having 300 megahertz, 500 megahertz frequency or capacity. What will happen there? The delta value definitely increases, and 1 ppm represents the greater number of HZ and it minimizes the second order effect. So whenever we are having the second order effect in the AB system, and when we use higher magnification spectra, that is 300 megahertz frequency, and this first order spectra will be this minimized, and second order second order spectra is increased. Minimize the second order spectra and increase the first order spectra. Look at this, how that AB spin system is there. Look at this, how this spin system, AB spin system is there, which contain first order and second order spectra. Now, what I have explained, that when we have the delta V upon delta J, that is greater than 100 or greater than 1, then we can have, it is first order spectra. So look at this, this is the AB spin system, delta V upon delta V upon J is equal to 0.4, here 0.1, delta V upon J is equal to 1, here 4, and here 15. So see here, so look at this peak. So this peak, this peak, this peak, and all this peak, all four peaks are of one kind. All four peaks are one kind. This is of the same picture, this is of the same compound, same compound, same compound, and same compound. So all these four showing the same compound, but how they are different, showing the peak, how they are splitting pattern or changes. In this case, that we are showing the singlet, and only two small peak we are observing here. So look at this 0.4. In that case, this is called as first order spectra. And whenever we are having this one, it is again the small peaks are trying to develop, and the middle peak which was showing in the first order singlet, that is going to change this into doublet. And see the difference between these two peaks, they are little bit very small. But when we go for the next, this difference of the peaks, doublet having the difference, and these two peaks having the difference. And lastly, we can have two double doublet away from each other, and they are showing the clear cut picture. So by that way, initially first case, it is showing the first order. This is showing a first order, and second and third week, third and fourth week, that is showing a second order peak. And look at this once again, AB2 spin system, where first order, second order spectra is observed. Now see here once again. So this is AB peak. This is AB peak. See the difference between those two peaks. They are close to each other. They are close to each other. And in that case, delta value is 0.4. And look at this AB. These are again, therefore it is called as first order spectra. Again, this is called as first order spectra. AB, look at this A and B. They are little going away from each other, and therefore they are making the space between two lines. Making the space between two lines, and this is clearly visible in the second picture, but it was not visible in the first picture. So again, these two lines or two pictures are called as second or first order spectra. Whenever we have this J is equal to delta V upon G is equal to 4 and delta V upon G is equal to 15. In that case, look at this. Peaks are having distance. J means coupling constant is going to increase. Here coupling constant is going to increase largely. Therefore, these are called as second order spectra. So delta V upon J is greater than 10. Delta V upon J is greater than 10. The first order spectra must pass a symmetry of test. It means that when we are getting the symmetry of the picture, it means that when I am having this kind of things, if I go or take the two part of it, if I divide this section, I can get two equal part. I can get two equal part. Therefore, it is giving a first order spectra. So again, this is the characteristic property of the first order spectra. You are getting the symmetry at the midpoint of the peak. Any two chemical equivalent nuclei must have the same coupling constant to every other nucleus. Any two chemical equivalent nuclei must have the same coupling constant. If coupling constant are same, similar fashion, definitely these two protons are coupled with each other, and they are coupled. If coupling constant of both the protons are different, definitely they are coupled with a different type of protons. Nuclear pair that fail this test are said to be magnetically non-equivalent, and their spectral character appearance is called as second order spectra. It means that if two protons are not coupled with each other and they don't have a same coupling constant, or if they are magnetically non-equivalent, then they are called as second order spectra. It means that if I am having the CH3 like this peak, if they are having the matching with each other, they are equivalent, and in this case you are getting the first order spectra. But by the force of some things, if these two CH3 protons are different and showing the unequivalent spectra or not equivalent equivalent proton, then they are called as second order spectra. So this is the, again, we have taken that consideration, the detailed information about the second order spectra, first order spectra. That part already we have seen. Now see this, actually what that spectral lines are far away from each other, and how they are showing the spectral lines and how they are getting the differentiation. So this is the showing the second order spectra. Look at this, the ABX spectrum. The X nuclei is coupled to the two nuclei A and B, and that are closely coupled with delta V AB divided by J is less than 10. It means that that value is very less than 10. When that value is less than 10, it is always second order base spectra. If that value is greater than 10, it is observed as a first order spectra. And definitely, so delta J upon delta JAB upon J, that is less than 10, then it is called as second order spectra. So there are different kind of second order spectra, just like A dash, X dash. Spectrum often is observed as a deceptive sample pair of triplet resembling A to X2. Means there are some cheating, that is some deceptive nature of the spectra. So you can consider this first order and second order spectra as well. When we consider this kind of spectra, methyl resonance at 60 megahertz instrument, you are getting only the single spectra. You are getting only single spectra, and because it is not having the clear picture of the splitting pattern, and therefore we can say that it is not separated. Definitely, it is complicated, and that will show first order. But if it is separated, we can say that it is the second order spectra. So you can say that one more important thing, whenever we are having the vicinal coupling, geminal coupling. So depending upon that coupling, you can also decide that whether that particular molecule have a second order spectra or first order spectra, and what sense uh, they are interacting with each other. That will also the important things. So with this we have finished this first order spectra and second order spectra. You go to the internet and see the information in detail. You will get so many points on the internet regarding the first order and second order spectra. But at this moment, you should know what is the meaning of first order spectra and what is the meaning of second order spectra. In shortly, I will say that it is very simple one. The first order spectra and in second order spectra, the difference is delta V upon delta J. One case it is greater than 10, and in another case which having the second order spectra, that value is less than 10. So that's the difference, and that is definitely if it is given in the problem, you can observe that whether it is second order or first order spectra. Again, for the presentation, I have used this PS Kelsey books, Kavia books, and Maya Sharma book of organic chemistry, especially spectroscopy book for making the presentation. Now, I will ask question to the students. If we have